Sample problem number 1 about electric dipoles. So a dipole with a moment of magnitude 0.02 e nanometer makes an angle of 20 degrees with a uniform electric field of magnitude 3 times 10 to the 3 Newton per coulomb. Find the magnitude of the torque on the dipole. So this is a very straightforward problem. So in our class, we know that the magnitude of torque is equal to the dipole moment, the magnitude of electric field, tapos the angle sine theta. Okay? So just have to put all the values here. So your P, however, is a dipole moment, which is equal to 0.02 E times nanometer. So your E here is a fundamental amount of charge. You already know that. 3 times 10 to the 3 Newton per coulomb. Tapos meron tayong sine of 20 degrees. Okay, so pupunin muna natin si P. So P is actually equal to 0.02. I-multiply lang natin yan ng E, which is equal to 1.60 times 10 to the negative 19 coulomb. Tapos si nanometer. Okay, so we have here 0.02 times 1.60 times 10 to the negative 19. So we have 3.2. So I would just put here 3.2 times 10 to the negative 21 nanometer. But nanometer is actually not an SI unit of the length. So dapat i-convert natin siya sa meter. So we just have to multiply this one by times 10 to the negative 9 meter. So how much is a dipole moment? So meron ding column dito. Kalimutan ko. Times C. So that is times 10 to the negative 9. So basically that is 3.2 times 10 to the negative 30 coulomb times meter. Then you can now proceed to the calculation of torque. So we have here P, which is equal to 3.2 times 10 to the negative 30. Then your E is equal to 3 times 10 to the 3 Newton per coulomb. Tapos the angle between them is sine of 20 degrees. So we just have to multiply this with 3 times 10 to the 3 tsaka times sine of 20. So that is equal to 3.28 times 10 to the negative 27 Newton times meter. So the magnitude of torque is actually equal to Newton times meter. Okay, so that's it. That's the magnitude of torque. So let's proceed to sample problem number 2. So straightforward lang din ito. So electric dipole consists of a particle with a charge of negative 6 times 10 to the negative 6 coulomb at the origin, and a particle with a charge of positive 6 times 10 to the negative 6 coulomb the x-axis at x is equal to 3 times 10 to the negative 3. So we have to find the dipole moment, the magnitude, and direction. Okay, so for letter B, or sample problem number 2, so that is like P is equal to QL. So Q here is the one of the magnitude of the charge, which we can say that the magnitude of the charge is 6 times 10 to the negative 6 coulomb, but the length is the distance between them. So that is like 3 times 10 to the negative 3. Okay, so meaning, so if we have to draw first the electric dipole, so ito siya. So meron tayong x-axis. So at the origin, nandun si negative 6 times 10 to the negative 6 coulomb. Ito yung origin. Now at the x is equal to 3 times 10 to the negative 3 meters. So ito yung positive 6 times 10 to the negative 6, diba? And the dipole moment always points from positive, from negative to positive. So ito yung dipole moment natin. Okay, So that is in I hat direction. So therefore, you expected that your P must be in I hat direction. Okay, so your L is a vector quantity, the distance pointing from negative to the positive, since same lang din ng direction ng P at saka L. So what is your L? So that is 3 times 10 to the negative 3 meters, tsaka I hat, kay since it is along in the positive x direction. So we have here, I just have to calculate this one. So that is 1.8 times 10 to the negative 8 coulomb times meter positive I hat. So yung magnitude ng dipole moment mo is 1.8 times 10 to the negative 8. Tapos yung direction is along the positive x-axis or from negative to positive. So pointing from negative to positive, okay lang din yun as direction. Now, the last problem about electric dipole. So 3, a uniform electric field of 300 nanocoulombs. So electric field, meron tayong magnitude which is uniform, 300 nanocoulomb, makes an angle of 25 degrees with the dipole moment of an electric dipole. So 25 degrees yung theta natin kasi ito yung angle between P at saka ni E. So if the torque exerted by the field has a magnitude of 2.5 times 10 to the negative 7 Newton times meter, what is the magnitude of the dipole? So straightforward lang din. So yung torque natin is given as 2.5 times 10 to the negative 7 Newton times meter. So from our equation, torque is PE sine theta. So kukunin natin si P, so by dividing E sine theta both sides of the equation, so si P mo is actually equal to torque divided by E sine theta. Okay, so torque is equal to 2.5 times 10 to the negative 7 Newton times meter divided by the electric field, which is 300 Newton per coulomb, then sine of 25 degrees. Okay, so how much is the magnitude of the dipole moment? So that is equal to, so I will just, so that is equal to 1.97 times 10 to the negative 9 coulomb times meter. So ito yung dipole moment na magnitude. Okay, so yun lang about electric dipole. So bye!